This is the recording that never ends. Oh, it just seems like I feel like I'm down here in my studio all the time with my Dunkin' Donuts coffee. If it wasn't for Dunkin' Donuts, who doesn't, by the way, sponsor me, but could. Look at that. Come on. Tell me that's not a face for lots of money for... No, I'm just kidding. Anyway, Mr. Key is held to help ye. Oh my gosh, the comedy never ends. Oh gosh, kids. Maybe that's what I should have done. Maybe I should have gone into comedy. All right. Write the inverse of no problemo, dude. All right, so if you remember with inverses, we got a y and we got an x. And when we got a y and an x, we switch them. That's it. Okay, let's rock and roll. First of all, I don't even have a y, so let's write it with a y, just so you don't get all confused. 8x minus 32. Okay. Now we're going to switch the x and y, so just the y comes over here, and just the x, boom, pops over there. So we get x equals 8y minus 32. Oh my God, the quarterback is toast. Little Die Hard reference. All right. Oh crap! We still got to solve for y. That's kind of stinks. So we got to solve for y. So we're going to bring that 32 over. We're going to say x plus 32 equals 8y. We still don't have y by itself, so now we got to divide by 8. Divide by 8. So I end up with y equals x plus 32 over 8. Now, if you don't like that, you could rewrite it as x over 8 plus 32 over 8. And then there's somebody going, but Mr. Graves, you can simplify. You can write it as x over 8 plus 4. Or you can write it as 1/8 x plus 4. Now, this is probably the best form for graphing, but this is good enough. But the final answer has to be given in inverse notation. An inverse notation. And so what you have to do is come back up here and say f of negative 1 of x equals, and then pick and choose your, x plus 32 over 8. All right, chilling. We have a y equals here, so what we're going to do is we're going to take this y. You don't like that half? We'll get rid of it. We'll take care of it. This y is coming over here. Goodbye, x. You're getting replaced. Oh, wait, where am I going? Oh, I'm going over here. Tell me, who has more fun with math? I mean, that's awesome talk. Like the y going to talk to the x, and the x going to talk to the y, and they're moving, and they're talking, and they're having a great time. All right, so we end up with x equals 1/2 parenthesis y plus 5. Now, if you're not in my class, you may not know this, but we do have a few legal F words you're allowed to use. The first one, of course, is fun. If you're in math class and you're having fun, you're like, fun this, man! It's so much fun! Get it? But if you're also having fun, but you'd like to use a different word, you'd say fraction. Like, this is a fractioning problem, or this fractioning stinks, man. Factoring would be another F word you're allowed to use. Factor or the included factoring. So, factor this, Mr. K. What'd you say to me, bro? Oh, good. You said factor. Love that F word. Anyway, fractions, everybody hates them. We don't like fractions, so I want to get rid of this 1/2. So what I'm going to do is I'm going to multiply this side by 2. But I figure if I do that side, I better come over here and give a little love to the x too, because you got whatever you do to one side, you got to do the other side, right? Otherwise, you're kind of like a hater. I don't know what that means, but this 1/2 will cancel with the 2, and that's why we do it, because that is the fastest way to get rid of a fraction, and then we just end up with y plus 5. Bring the 5 over, I get 2x minus 5 equals y. Now, the original wasn't written in function notation, which it probably should have. If this is written in f as f of x, which it probably should have been, then this would be f inverse of x equals 2x minus 5. All right, so now we're going to do something a little bit more complex. Just a little bit more complex. It said find the inverse of this and use composition of functions to verify that the two are inverses. So let me explain what this means. Using composition of inverses of composition to verify that they're inverses. What that means is this. If you take f of f inverse of x, so you're going to take the function of the inverse, it should be equal to x. And that's how you verify. So I'm using this as an opportunity to learn about inverses, or remind yourself about inverses, but also remind you that of how to do composition of functions. So let's write this as y equals, well, it's not bad, it's a little weird, but y equals 1/4 x minus 5. We're going to have a little fun. Y is coming over. It's like Angry Birds. Angry Birds coming, knock you out, bro. And then you're like, oh, I'm going to get you. I'm coming back over here to get you, bro. That's what I'm going to do. I'm going to call it the Angry Bird inverses. That's so cool. All right. If you had coffee in the morning, you'd think that was cool too. I'm either encouraging you all to drink coffee, or you're thinking, I'm never touching that stuff, because if I ever am that bald and that weird, I don't know. All right, so that's what we do first. There we go. We got it. Oh, you don't like that 5? You're a 5 hater? You hate 5s as much as everybody else? So what we're going to do is we're going to, excuse me, not 5. It's this 4 that's the problem. So what we're going to do is we're going to go through and multiply everything by 4. We're going to multiply this whole side by 4, but that means you got to multiply both of them by 4. And we're going to multiply this side by 4. So I end up with 4x equals, these just cancel, y minus 20. Bring the 20 over, and I get 4x equals, excuse him, what? That was French, by the way. I'm French. Plus, yeah, if you think I'm French, you got another thing coming. German. Ich bin ein Deutscher. Ja, natürlich, ich kann Deutsch reden mit dir. Das ist kein Problem. Wir können die ganzen Tage Deutsch reden. Just a little fun. Anyway, that was a little bit German for you. F inverse of x, I thoroughly got you guys all messed up now, is equal to 4x plus 20. But we still have that second part of the job, and that is to say that we're going to take f of f inverse of x, and it has to equal x. All right, so we're going to take f. F says this. Well, here's what we're going to do. We're going to f of 4x plus 20. Now, f says to do this. We're going to take 1/4 times whatever's in the parentheses minus 5. Now, this thing here is the thing that's in the parentheses. So we're going to take the functional value at that function. So 4x plus 20. Now we're going to distribute the 1/4. So 1/4 times 4 is x. 1/4 times positive 20 is positive 5. Bring down the minus 5. You'll notice that the minus 5 and the plus 5 cancel, and I'm left with just x. So f of f inverse of x does in fact equal x. Therefore, they are in fact inverses, and you did it correctly. You got one more to try. Oh, look at that. It's an effing fraction. I mean, it's a fun fraction. Fun fraction, you get it? Because it's the F word you're allowed to use. Get it? Oh, my God. All right. So, let's write it. Oh, and it's k equals, who cares? K of x. Y equals 2x minus 4 over 3. Then we got to Angry Bird it. Boom! Knock you out. Angry Bird says knock you out. Mama says knock you out. That goes over there. So we get x equals, right? 2y minus 4 over 3. Don't like the 3? Nobody likes the 3. So we're going to come through and we're going to multiply this whole side by 3. And we're going to multiply this whole side by 3. Gone. See it. Wouldn't want to be it. You ugly and your mama dress you funny. 3x is equal to 2y minus 4. My mama don't dress me. My daddy does. What? Coffee. Drink more coffee. Let's solve for y. I'm going to bring the 4 over, so I get 3x plus 4 equals 2y. Divide by 2 and divide by 2. And I'm going to leave it just like that. So f inverse of x is equal to 3x plus 4 over 2. Yes, it's going to be a pain in the neck. So here's what we got. We're going to do, oh, it's not f. Ooh, that was kind of silly. I forgot we were working with the k function. So k inverse. Don't make a silly mistake like that. So now we're going to do k of k inverse of x. And we want to verify that it equals x. That's our goal, okay? So we're going to do k of 3x plus 4 over 2 equals... Now, the k function says, the bottom's just a 3, take 2 and multiply it by whatever's in those parentheses and subtract 4. So this thing goes in here. So we're going to have 2 times 3x plus 4 all over 2 minus 4, and that whole thing is over 3. So the only thing I did was replace this and put it in the parentheses where it goes. Okay? So now what we're going to do is we're going to distribute that 2. But wait a second. This 2 and this 2 actually just cancel each other out. So what I'm left with is 3x plus 4 minus 4 all over 3. Well, these cancel each other out. And so what you end up with is 3x over 3. Those cancel, and I'm left with just x. Magic! It worked. Going on. Oh, wait, hold on. I gotta pause for a minute to save and then move on. And then we're going to talk about inverse variation, or varies inversely. The kids just don't. Hi, kids. I'm back. Oh, let's get going. All right. The number of hours H it takes for a block of ice to melt varies inversely as the temperature T. So we have H and T. So here's the thing. As soon as I see these words varies inversely, I know as one goes up, the other one goes down. As one goes down, the other one's got to go up. But all it does is satisfy the equation xy, or x times y, is equal to x times y. So in this case, it's not x and y. Now, what is x and y? X and y is whatever in the problem. In this case, it's not x and y. It's h times t. Hours times temperature is equal to hours times temperature. Varies inversely. That's all it is. Sorry, I'm using the free version. So let's see what we got here. If it takes 2 hours for a square inch of ice to melt at 65 degrees, so 2 hours at 65 degrees, how long will it take to melt at 43 degrees? How long? Hours times 43 degrees. That's it. I want to solve for hours. I just divide by 43. I divide by 43. Boom, boom. Pump that baby in my calculator. Shut up. Get off my calculator. 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 2 times 65. 2 times 65. 2 times 65. Enter. Divided by 4 equals 65 over 2. Of course, you're not going to be nice. Control Enter. 8.125. So the number of hours is 8.125 hours. Okay, there you go. Oh, no, that didn't work out right. Something's not right there. Let's try this again. I'm going to do control division. 65 times 2, we'll put a decimal point in there, divided by 4. Enter. Oh, it's 43. That's the problem. I knew something didn't make sense. All right. So all we're doing is dropping the temperature by about half. So this thing ought to go up about twice as much. So if this drops about half, this is going to drop twice as much. It's not going to go up twice as much. But I'm supposed to be dividing by 43. God, I've taken an easy problem and made it like look hard. It's not. There it is. It's 3.02. Round to the nearest hundredth of an hour. So we're going to write h equals 3.02. 325, hundredth of an hour would be right there, so h equals 3.02. Sorry about that. The number n of photos in your digital camera can store varies inversely. There it is again, varies inversely. So as soon as I see the words varies inversely, I'm going to write x times y equals x times y. Now in this case, again, let's make it make more sense. We've got photos n, and we got size in megapixels. So we're going to do n times s is equal to n times s. It makes it a little bit more meaningful for this problem. So as your digital camera can store 54 photos, that's the number of photos, 54. I shouldn't be writing that over there. Let me bring it back over here. 54 photos times 1.92 megapixels. We don't have to put the units on there. Is equal to, write a model that can give n as a function of s. And the average photo's size is 3.8 meg. Oh, well, all right. N as a function of s. So what they want you to do is equal to n times s. That's the first part. They want you to give n as a function of s. So we're just going to divide by s. So n is equal to, I don't know what 54 times 54 times 1.92. Hopefully it's something nice. 103.68. So it's n is equal to 103.68 over s. So there's your function. Now they're saying, okay, the megapixels are 3.87. So if I take 103.68 and if I divide it by 3.87, I should be able to get it. And divided by 3.87, I get 26.79. 26.79. 069. 069. How many photos? So since I can't have, this is a tough question. How many photos can your camera store? So here's a tough question. This looks like you'd round it, doesn't it? But remember, this just isn't quite enough to get the next picture. So think about let's say this is your photo bucket, and you're like, okay, the 27th photo was right here, and in order to get that 28th photo in, I need about this much room. It's just not quite enough to get that 27th picture in there. So I can get 26 in, but to get that 27th just goes a little bit past the storage capability of my thing. So and this is a case where you wouldn't round, you'd get n equals 26. That's it. All right, the volume V of a gas varies inversely. There it is again, kids, varies inversely. So we've got gas, volume, and pressure. Volume and pressure. So I know it's xy equals xy, but in this case it's going to be volume times pressure equals volume times pressure. If the volume of a gas is 200, don't worry about the units, and the pressure is 1.6, find the volume to the nearest tenth when the pressure is 2.8. So we got to get volume when the pressure equals 2.8. That's it. That's the problem we're going to solve. We're going to divide by 2.8. And we're done. So 200 times 1.6, enter, divided by 2.8. 114. Now write down what the answer is. 114.2 85714. 85714 rounded to the nearest tenth. So the volume is equal to 114.3. And don't put the units. That's what it is. All right, I'll be back. More coffee while I'm on break. All right, your life expectancy. This is a dumb question. Your life expectancy varies inversely, is inversely proportional, varies inversely to the size of your waist. All right, I'm in trouble. Not really. My waist size is 33. I should have used 33. I lived to 100. All right, so let's see. If your waist size is 32, so this is waist size times life expectancy is going to equal waist size times life expectancy. So if my waist size is 32, I expect to live to 90. What does my waist size have to be? I think I wrote the problem wrong, but let's stick with it. If my waist size is 100, that's ginormous. But let's say your waist size is 100. Let's see how long you're going to live till. Sorry about this. We're going to divide by 100 and divide by 100. And somewhere around 27. Let's see. 32 times 90 equals, and then divide by 100. Control Enter. Well, we're going to live till... that didn't work out right. Let's do this. Enter. Let's change one to a decimal place. 28.8 years. So L equals 28.8 years. We can expect to live to about 29 years old. Woo. All right, kids, here we go. Absolute value functions. Oh my God, they're so much fun. One of the things you got to remember about absolute value is the absolute value of -2. If I have this question, the absolute value of x equals 2, I know that I can plug a -2 in here and a +2 in there, and they both work. And that ought to remind you, oh yeah, absolute values almost always have two solutions. So the first thing we want to do is get the weird thing alone. This is the weird thing. Always get that weird thing alone. There's the weird thing. So we're going to get that by itself by moving this over, by adding it. So we end up with the absolute value of 2x plus 5 equals 7. Now we split it up into two problems. The original, 2x plus 5 equals 7. Don't ever mess with the left side. 2x plus 5 equals -7. And those are the two equations that I have to solve. So I get 2x equals 2, x equals 1. There's one of my answers. 2x equals -12 because I subtracted 5. Or x equals -6. There's the other. Make your answers look professional. 1 and -6. Look professional. Make the grader go, man, this kid knows what he's talking about. I would check those. I'm not going to. I might check one. All right, so now let's talk about a little bit more realistic of an Algebra 2 question. All right, so we're going to take the weird things already by itself, and it's equal to, and I'll put this in parentheses, it's equal to this. So we're going to write the original, x minus 2 equals 3x plus 10. That's the original, no changes. And then we're going to write the negation of the right side. So this becomes x minus 2 is equal to the negation of 3x plus 10. Now you see why I put it in parentheses? Because we're really going to have to distribute that negative. So this one, let's see, I'm going to bring the x's over here. So subtract x, subtract x. I'll bring this over to the other side. Minus 10, minus 10. So I end up with -12 equals 2x, or x equals -6. Over here, I end up with x minus 2 equals -3x minus 10. I'm going to add this 3x, so I get 4x equals, add 2, I get -8, or x equals -2. Now, you really, 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 really should check these. So let me erase this. I'm going to leave it, of course, I'm going to give my answers if they check in curly brackets. Not sure if these ones are going to check. We'll see. So I'm going to go to my calculator and store -6. So -6, stow x. And I go in here, absolute values. There it is right there, the second row. Absolute value of x minus 2. X minus 2, and hit enter. And then I'm going to type 3x plus 10. And hopefully they're the same thing. That's weird. That didn't work. All right, let's try negative 2. Negative 2 control var x. If they both don't work, I probably did something wrong. That's 4. And that's 4. So the negative 2 worked, but the negative 6 did not. So that's not a solution. So I get negative 2. You always, always, always should check your absolute value functions. All right. So this one we get the absolute value of 4x plus 6 equals 4x minus 10, because I brought that over. So now we're going to write 4x plus 6 equals 4x minus 10. And then we're going to write 4x plus 6 equals negative 4x minus 10. Oh, that's weird. So this one, if I subtract 4x and I subtract 4x, I get 6 equals negative 10. There's no solution there. That doesn't work. This one I get 4x plus 6 equals negative 4x plus 10. If I bring this over, I get 8x equals 4, or x equals 1/2. Maybe that's an answer. I'm going to check. So I'll take 0.5 and I'll stow it into x. And then I'll type in the left side, absolute value of 4x plus 6 minus 4x. And it equals 6. And we want it to equal negative 10. So apparently either I'm crazy or there's no solution. All right, I got time for one more. Not here. Last problem. All right, so now these are absolute value inequalities. They're kind of done the same way. You're going to write the original, no change to the left side, no change to the right side. But for the other one, you're going to only change the right side plus this gets changed. So it's 3x minus, 3 minus 2x. Now we're going to switch everything else. The left side never gets changed, but the right side is going to switch. Greater than or equal to negative 4. So these are the two equations we have to solve. I'll start solving this one first. So this negative makes me nervous, and you'll see why in a second. The negatives really should make you nervous when you're dealing with inequalities. So we're going to subtract this 3, So I get negative 2x is greater than or equal to negative 7. I'm going to divide by negative 2, and there's where it makes me nervous. I hate dividing by negative 2. I get x. Now, you have to remember, when you divide by a negative, you have to remember to flip that sign. And then 2 negatives make a positive, 7 over 2. All right, now we're going to solve this one. We'll bring the 3 over. Wham. So I get negative 2x is less than or equal to 1. We're going to divide by negative 2. Divide by negative 2. Since we're dividing by a negative, we got to switch the sign. X is greater than or equal to negative 1/2. Now comes the issue. Here comes the hard part about this. And the easiest way to think about this is to graph it, because I need to know whether or not I write this as a conjunction, an and, or a disjunction, an or. I need to know if I'm going to write an and or an or. Now, ands have to be done a little bit differently than ors, but we've got to decide, because you can't leave it this way. So the easiest way to do this is to try to put this on a number line. So there's 0. 7 over 2 is 3.5. 1, 2, 3, 4. So there's 3, there's 4. And then negative 1/2 would be down here somewhere. So this one says a closed circle at negative 1/2, and I'm going greater than that direction. This one says a closed circle at 3.5 or 7/2, and I'm going less than. Notice that I'm connecting the dots. This is an and. If you go in opposite directions, this direction and this direction, that's an or. This is an and. So it's not good enough to leave it like this. You have to write it as a conjunction where x goes in the middle, we're less than or equal to 7/2, and we're greater than or equal to negative 1/2. There it is. That's the answer. All right, kids, that's it. I'll be back tonight sometime after dinner. But it's been fun working with you so far. Drink your coffee. No, you don't drink your coffee. You're too young for coffee. Bye. I'll be back in a couple hours. That seemed like 2 seconds for you. I just spent the entire day at school. It's 10 o'clock at night. I'm really tired. We got to get moving. We got to get this done. We got to rock and roll. All right. I've got an inequality. As soon as I have an absolute value. I have an absolute value inequality. As soon as I see these absolute value bars, by the way, I'm thinking, I don't know if I said this before, but the first thing I'm thinking is, man, I got 2 equations. And we got to get this weird thing alone. We're going to get this weird thing alone. It's weird. So we're going to get it alone by subtracting 4. And then I get negative 3, absolute value of 6 minus x is less than negative 15. We're going to divide by negative 3, which makes me nervous because I think you're going to screw something up. I hope you don't. What you get is the absolute value of 6 minus x is greater than positive 5. When you divide by a negative, you have to flip the sign. All right. So now that we've got it solved for the weird thing, we're going to split it up into 2 equations. One, we don't touch. We just get rid of those absolute value bars. Nothing changes. Oops. Don't know why I wrote 0. I'm probably going to be making a lot of mistakes. Hope not. 5. The other one, don't touch the left side. Only touch the right side. So 6 minus x less than or equal to negative 5. Notice all of this stuff changed. Okay? You don't mess with the left side. You just change everything else. All right? I just solve it. Oh my gosh, I got another negative x, which means I'm going to be flipping signs. Not flipping off, flipping signs. I'm going to subtract 6. So I get greater than negative 1. Divide by negative 1. Divide by negative 1. And I get x is less than 1. Okay, over here, I'm going to subtract 6. So I get negative x is less than negative 11. Divide by negative 1. Divide by negative 1. And I get x is greater than positive 11. Well, this one you got to draw and figure out what the heck's going on here. So I got 1, and we got an open circle, and we're going that way. I got 11. We got an open circle, and we're going that way. So this is an OR. So this is an OR. And if I'm correct, the direction said write the answer in interval notation. Now, if they asked for standard notation or they didn't care, you can just write an OR in here, and it's between that thing and that thing. So that would be correct. But they asked for it in interval notation. So let's take care of this in interval notation. For this one right here, it points to negative infinity. And it goes all the way up to 1. But it's a parenthesis because you can't equal 1. Union symbol means OR. For this one here, it goes all the way to positive infinity, but starts at 11, parenthesis, and parentheses. So that would be the answer to this question. 14. First thing I'm going to do is get rid of this half. I'm going to isolate the weird thing. So I end up with the absolute value of 4 minus 2y is greater than 8, because I just got rid of this half. Isolated the weird thing. Now I'm going to split it up. This one doesn't change. It's 4 minus 2y. Uh-oh, we got a negative thing we're going to divide by, so we got to remember we're going to eventually switch the sign. And then 4 minus 2y is less than negative 8. Not going through the whole lesson on why that's true. That's how it's done. You should remember this. Solve it. I'm going to subtract 4. Subtract 4. So I get negative 2y is greater than 4. Divide by negative 2. There's that negative 2 we're dividing by. So you got to remember you're going to flip the sign, right? Don't forget that. Y is less than. I don't know why I put 22. That should be negative 2. Y is less than negative 2. And over here we're going to subtract 4. And we get negative 2y is less than negative 12. Divide by negative 2. There we go, and divide by negative 2 again. So I get y is greater than positive 6. And once again, I'm pointing in 2 different directions. Here's negative 2. We're going less than. Here's 6. We're going greater than. So this is an OR. How do they want the answer in? In interval notation again. Now, if they ask you to want it in standard notation, just say y is less than negative 2 or y is greater than 6. But they didn't. They said they wanted it in interval notation. So the u represents the or points to negative infinity. If it's ever an or, you're gonna have infinities on the outside, and then you just put these two numbers on the inside, comma -2, 6 comma no equal sign, right? There was no equal sign in the original problem. Just make sure, and therefore just parentheses. So there's the answer to the question. All right. Now we're going to do, I know I'm mixing things up on you. Now we're going to do some binomial probability. Hopefully you've covered this already. Binomial probability. As soon as I see one of these kinds of questions where it says probability of winning is this, what's the probability of winning exactly, how many games, 2 games. This is, the first thing I'm going to think about is N, R, P, and Q. Now if your teachers didn't fill this in or do this way, I don't know how to tell you. I'm going to try to make sense of this. Hopefully they do it this way. N stands for the number of events. So in this case, we're going to play 3 games. I want exactly 2 games. So R is 2. The probability of winning is 5, 6. These two things always have to add up to 1 because this is the probability of the thing happening, and Q is the probability of it not happening, 1/6. So now I just set it up. 3, choose 2. In the first one goes P to the number we want. We want 2. In the second one goes Q, the number we don't want, 1. These two things have to add up to N. Must add to N. 3 in this case. So now I just type this thing in my calculator. Oh, don't have my calculator up. I knew I forgot to put something up. I knew I was going to need it too. Shouldn't take long. My computer's pretty fast. Got a new computer. It's pretty fast. Wow. Where'd it go? Oh. Would be faster if I didn't have the free version. Anyway, all right. So we're going to... So we'll go to the calculator. And we're going to type in menu 5, 3. That gives us this. It's 5, 3, 2, 3, 2. Don't care really what that is. Times parentheses 5 divided by 6 parentheses squared 1/6 parentheses 1 divided by 6. I don't need to put to the 1th power because it's just 1 automatically. Type that in. I get 25 over 72. 25 over 72. Boom. Boom, you can leave it just like that. This one's going to be a little bit more difficult. If the probability that the girls lacrosse team winning is 5/8, what's the probability? These things make it more difficult. This at least makes it more difficult. Now, everybody thinks at least means less than. At least does not mean less than. Think about the drinking age. How old do you have to be to drink? You have to be at least 21. That means 21 or greater. In this case, it means 4 or greater. So when we go and do our N, R, P, and Q, N, P, and Q are pretty self-explanatory. We're going to get 5 games. The probability of winning is 5/8. If the probability of winning is 5/8, the probability of losing is 3/8, because remember, these things have to add up to 1. This is where you're going to have problems. If it's a 2-point question, it's probably exactly like the last question. In this case, it's at least 4 games. That means 4 or 5. And because there's 2, 1 and 2, I'm going to have 2 equations. It's going to go 5 choose 4 and 5 choose 5. Why are you up? Get away from me. You're ugly. All right. In the first one goes 5/8. And the second one goes 3/8. And what do we want to happen? We want this goes here. We want 4 wins, and that would be 1 loss. Or we want better than that. We want 5 wins, and that would be 0 losses. Well, 0 I don't even need. Psh, gone. So in order to get credit for this, you have to show your answers. So let's see. Go away. All right. I'm going to do menu 5, 3, 5, 4, 5, 4, 4. Hit the times button, 5/8. parenthesis 5 divided by 8, parenthesis raised to the 4th, parenthesis 3 divided by 8, parenthesis raised to the 1. I don't even need that, but I'll put it in there, raised to the 1. You don't need it, but whatever. 9375. So 9375 over 32768. 32768. That's this one. Sorry, I ran out of room to show it. But to that, we're going to add whatever this one is. Well, that's the exact same thing, except we're going to modify it just slightly. We're going to change this to a 0. We're going to change this over here to a 5, and we're going to change this to a 5. Lots of kids forget to change things. It might be better just to type everything in new, because sometimes you forget to change all the things you have to change. Hit enter, and you get 3125 over that same denominator. So 3125 over 32768. We add those up, so we say plus this. So adding those two up, and it's 3125 over 8192. Sometimes they ask for the decimal. So you just go up here. In this case, you just go up here, put a decimal on one of these, and press enter, and you get 0.38146. 0.38146. And then so they would tell you to round. You don't need to do that. When Cameron races, he wins 60% of the time. What is the probability he win at most? Now, at most means that's the most he's going to win 2 of the next 6 matches. So N, R, P, and Q. Remember, N and P and Q are easy. They're not the bad ones. N, we're going to go 6 matches. P, 0.60. That's 60%. Remember, they have to add up to 1. So the probability of losing is 0.40. Really don't need the 0. And at most 2, that would be 0, 1, or 2 in this case. So I can do 0, 1, or 2. So we're going to have 3 equations in this one. 6, choose 0. 6, choose 1. 6, choose 2. Ching, ching, cha-ching, cha-ching. Oh no, we should do this. 0.6, 0.6, 0.6, 0.4, 0.4, 0.4. Now remember, what goes here is this. So 0 is going to go here. 6 is going to go here. 1's going to go here. Sorry, this should be a parenthesis. 5 should go here. Remember, this number goes here. And they have to add up to 6. So 2 goes here, and they have to add up to 6. 4. All right, let's type the first one in. Menu 5, 3, 6, comma 0 times parentheses 0.6 parenthesis raised to the 0. I'm going to put that in because I got to change it later. Times parentheses 0.4. Remember, they got to add up to 6, so raised to the 6th. See, it gave me a decimal this time because I have decimals. So 0.004096. 0.004096. All right. Hit the up arrow. Change this to a 5. Change this to a 1. And change this to a 1. 0.036, 0.036, 864. 864. Got to write it all down. I don't know why. It seems like I should have more decimals on it, but no, it's good. I'm sure it's good. All right, and then go one more. Okay. Enter. Enter. Come on. We're going to change this to a 4. We're going to change this to a 2. And we're going to change this to a 2. Enter. 0.13824. 0.12834. Add them all up. You're going to take this plus this plus this 0.1792. 0.1792. Rounded to the nearest tenth. Oh, whoa! Tenth of a percent. Whoa, that's crazy. That's hard. Round to the nearest tenth of a percent. So the first thing I got to do is turn this thing into a percent. Right now it's just a decimal. I'm going to turn it into a percent by moving the decimal twice or by multiplying by 100. So it's 17.92%. Now if I round to the nearest tenth of a percent, the answer is 17.9%. Woo, that was a tough question. All right, 3 questions left. Binomial theorem. We're going to use the binomial theorem to expand this thing. So we start with this idea of this exponent. We're going to do 5, choose 0. Remember, we always start at 0. 5, choose 1. 5, choose 2. 5, choose 3. 5, choose 4. And 5, choose 5. Now, if you remember correctly, if you don't know these, just put them in. But if you remember correctly, it always starts with 1 and 5. 1 and whatever the exponent is. And if you put 5, choose 2 in your calculator, I'm not going to go through it right now with it. You get 10. You can do that in your calculator, 10. So now we're going to do 2 sets of parentheses afterwards. The 2 sets of parentheses are for these 2 things right here. Those are the things that are going to go in the parentheses. Those are the things that get the exponents. So we're going to start with 5. 5, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, 5. What goes in the first set of parentheses is 2x. Now, anything raised to the 0 power is just 1. So I really don't need this one. What goes in the second one is 5y. 0 power. Don't need that one. 5y. I might use it anyway. So what your goal is to do is now type all of this in, starting here, type all of this in, but just type in the numbers. So we're going to go to our calculator. We're going to go 1 times parenthesis 2. Don't type in the variables raised to the 5th. Now if you want, you can put in 5 raised to the 0, parenthesis, 5, parenthesis, raised to the 0. Enter, 32. So this becomes 32x to the 5th. No y's. The next one's going to have y's. So now we're going to type in all of these numbers. So I'm just going to highlight this. I should have used parentheses. Oh, I did use parentheses. So this is 5. This is 4. And this is 1. 400. 400. X to the 4th. Y to the 1st. X to the 4th. Y. Same thing. Enter. This is going to change to a 2. This is going to change to a 3. And I believe this is 10, right? 2,000. 2,000. X cubed, y squared. X cubed, y squared. Notice the x's are coming down, the y's are going up. All right, same thing. This is now a 3. The beginning number is 10 still, so we'll just leave that as 10. Divide on 2. 5,000. X squared, y cubed. Remember, they got to add it to 5. Now we're going to do it one more time. Oh, 2 more times. This is going to go to 4. This is going to go to 1. And this goes back to 5. 6250, 6250, x, y to the 4th. And finally, I really just need this, because 1 times whatever. I really just need to know what 5 to the 5th is. 5 raised to the 5th. And that's 3125. So 3125 y to the fifth. Now, you're not quite done, remember. This is a polynomial, so you need to give your final answer. My final answer is 32 x to the fifth plus 400 x to the fourth y plus 2,000 x cubed y squared plus 5,000 x squared y cubed plus 6250 x y to the fourth plus 3125 y to the fifth. Holy mackerel. They'll give you lots of room for that. I didn't, but they'll give you lots of room. All right, I should have saved this a long time ago. Two problems left. Two problems left. This one's a little bit shorter, but trickier, and the last one's really short. So we're going to start with 4. Go 4, choose 0. 4, choose 1. 4, choose 2. 4, choose 3. And 4, choose 4. If you type these into your calculator, again, I'm not going to do that. You guys know how to use combinations. This is going to be 1 and 1. This is going to be 4 and 4. This is the only one you may not know. I mean, you know, I'd show you one more time. Menu 5, 3. It gives you combinations. You're going to do 4, 2 and get 6. Boom, 6. There it is. So it's just 6. 2 sets of parentheses. Now, the thing that makes this one more difficult, I'm going to tell you right now. I'll highlight it in just a second. You might already know. And, you know, anybody that doesn't use parentheses when they put stuff in is a fool. This is why it's going to be more difficult, because of that negative. You just got to be careful. So 3m, 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 negative n, negative n, negative n, negative n, and negative n. And you got to really remember, that's really a negative 1 there. All right, so let's do these exponents. 4, 3, 2, 1, 0. Don't need it. 0, 1, 2, 3, 4. All right. So this one's not bad. If I type this in, 3 to the fourth power is 81. So this would be 81 m to the fourth. This one I'm not really sure of. It's 4 times 3 cubed. So let's do 4 times parentheses 3 parentheses cubed. Oops. Cubed. Now this is the hard part. You got to remember to put this in negative 1. It's really a negative 1. You got to put all the numbers in to the first. Oh, that's negative 108. That's what makes this one a little bit tricky. Negative 108 m cubed n. Now the next one's actually going to be positive. So we're going to do enter. Changing this. The reason it's going to be positive is because now you're squaring a negative, which makes it positive. Delete this, make it 2. And then I think this is a 6, right? Delete this and make this a 6. And we get 54. So we get 54 m squared n squared. Now the next one's going to be negative. So we're going to do 4. This one's cubed. This one's to the first and back to 4. Negative 12. Negative 12 m n cubed. And finally, negative 1 to the fourth is just positive 1. So it's just n to the fourth. And so my final answer here is 81 m to the fourth minus 108 m cubed n plus 54 m squared n squared minus 12 m n cubed plus n to the fourth. Whoo! Last problem. Now this one's a little bit easier, because this is how typically they answer the question. They only want the fifth term. So I want the 1, 2, 3, 4, fifth term. So here's what I'm going to do. I'm going to go 6, choose 0. That's 1. 6, choose 1. That's 2. 6, choose 2. That's 3. 6, choose 4. That's 5. No, is that 5? Is that the fifth term? No, I'm on the fourth term. 6, choose. 0, 1, I forgot 3. That's why I was messed up. I think that'll go away. 6, choose 3, and 6, choose 4. So this is my fourth term right here. 6, choose 4. Not really sure what that is. Menu 5, 3, 6, comma 4. It's 15. So this is equal to 15. Now I need my parentheses. Now notice I don't care about all the other ones. I just care about this one. 3x here, negative 2y here. Now I don't know about my exponents, so I'm going to count. Remember, count down. So this one would be 6, 5, 4, 3. This would be 2. This would be 0, 1, 2, 3, 4. Make sure that these add up to 6. They have to add up to whatever this exponent is. All right, I'm almost done. Type in all the numbers. So 15 parentheses, 3 parentheses squared, parentheses, negative 2 parentheses raised to the 4th power. 2160. So I'm going to write 2160 x squared y to the 4th. Oh, y to the 5th. I wrote y to the 5th. I said 4th, but I wrote 5th. Y to the 4th. All right, kids. That's binomial expansion, binomial probability, and all that other stuff we did today. Hit subscribe, hit like. You could donate if you'd like. If I really, really help you pass this test, and you could have been paying a amazing tutor. If not, you can also hit some of those links if you like. If there's something you're interested in. Anyway, I don't really care. I hope you do well. I hope you continue to study. Don't give up. Keep working hard. You can actually do it. It's so much time. You got a lot of time to study, and then boom, it's over with, and then you get to relax for the summer. All right. So I care about you guys. I want you to do well. Keep working hard. I shouldn't be working harder than you. You should be working harder than me. All right. Good luck, kids. Peace out.